Hello everyone. Today we are going to know about sliding window protocols in computer network. Let's see what is protocols. Protocols are two types. One is noiseless and one is noisy. We can study both. The study of protocols is divided into two categories as I already mentioned. Those that can be applied to channels with no noise or errors and those that can be applied to channels with noise or errors. Although the first group of protocols cannot be applied in real world situations, they provide a foundation of for protocols for noisy channels. We can see in the diagram protocols are divided into two categories. One is noiseless and another one is noisy. In the noiseless there are two categories: simplest and stop and wait. In noisy also contains three categories: stop and wait, arq, selective repeat arq, and go back and arq. We can see one by one. Let's see about the protocol definition. The protocol refers to a defined set of guidelines and regulations that control the communication between different devices in a network. These guidelines specify the way in which the data is formatted, timed, sequenced, and checked for errors during transmission. Protocols play a crucial role in ensuring accurate, efficient, and clear communication between devices. They make it possible for devices of different types brands to communicate with each other, and they provide a consistent method for transmitting data across a network. Headers are responsible for selecting protocols, which are rules governing communication between devices in a network. These headers contain information describing the message's nature and the handling it will receive. The noiseless channel, first we can see about the noiseless channel. It contains the two categories. One is simplest protocol and stop and wait protocol. First one is simplest protocol. A simplest protocol for a noiseless channel would be that one involves the direct transfer of data from the source to the destination without any intermediate processing. In this scenario, the channel is assumed to be noise free, which means the data transmitted remains intact and does not get corrupted. In a noiseless channel, a simple correction or flow control mechanisms is placed. This type of protocols is ideal for a noiseless channel as the lack of noise ensures that the data transmitted is received accurately, making the implementation of additional measures unnecessary. In order to create the simplest protocol, the following presumptions have been made. There is no whatsoever is the broadcast channel, a channel with no duplications, lost frames, or corrupted frames. The assumption is that the transmission route is perfect with no instance of data, a loss, duplication, or corruption. The senders and receivers end have endless amount of buffer space for the frames. Points to remember: the processing time for this technique is quite brief, so it may be discreted. Each party in the constantly prepared to send and receive data. Without giving the recipient any thought, the sender delivers a series of data frames. No data loss occurs, hence neither a acknowledged nor a not acknowledged is sent. The data is transferred to the following layer right away to the DDLL at the receiving end and after the frame header has been deleted. In the absence of acknowledgement or non-acknowledgement, it also known as NACK, the sender must wait a predetermined time before transmitting the message. As you can see, flow diagram is simplest protocol. Data flow diagram is a graphical representation of the flow of data in a system. In the context of simplest protocol, a DFD can illustrate the movement of data between the sender and the receiver. The DFD would show how the sender data frames under the receiver, uh, how the receiver, what happens if any error occur during the transfer, any error occur during the transfer. It could also show the absence of flow control or error control mechanisms, which are typically included in more complex protocols. Let's discuss about the diagram. The simplest protocol diagram is one is having the sender in the left side, receiver is the right side. One request is sent with the frame 0 and it is arrived in the receiver and receiver got acknowledgement. A second request is for also from frame 1 up to frame 1 and request. And there are all frames from 0 to n frames are received and acknowledged due to the receiver. An illustration of the Chopin protocol has been exchanged and shown in the figure. It's simple to understand. Following the transmission of a frame, the sender awaits the receiver's answer. Send the following frame after waiting for the acknowledgement. From the receiving end, keep in mind that every time there are two frames, sender is involved for four events and receivers are in two events. The second one is stop and wait protocol. Stop and wait protocol is a protocol that is used for reliable data transmission in a noiseless channel. In this protocol, sender sends a single packet at a time and waits for an acknowledgement from the receiver before sending the next packet. This way, the sender can ensure that each packet is received by the receiver and has been successfully processed. If the sender does not receive any acknowledgement with a certain time frame, the packet is considered lost and must be retransmitted. The flow of data frames at the receiver side may become too fast for it to be processed, causing the need for a temporary storage. However, the limited storage space of the receiver may result in the loss or discarding of frames, even denial of service. To prevent this, sender must slow down the rate of transmission, which is achieved through the use of acknowledgement messages from the receiver. The sender sends a single frame and waits for confirmation from the receiver before sending the next one, adding the flow control to the previous control. Flow diagram. As you can see, one is the sender A, receiver B. Request is sent to the receiver. It is frame one, and it is arrived. The receiver has sent acknowledgement. Next frame is sent once the acknowledgement is received by the sender, which is the previous acknowledgement for the previous frame, frame zero. The sender waits an acknowledgement from the receiver. The receiver processes the received data frame. The receiver sends an acknowledgement to sender to confirm the recipient of data frame. The sender continues the transfer to the next data frame, repeating the process of step one. Next, we can see the noisy channel protocol. Sorry, a noisy channel protocol is divided into three protocols. One is stop and wait protocol. First one, you can see the stop and wait ARQ, auto request. ARQ means auto request protocol. The stop and wait protocol is a protocol used for reliable data transmission over a noisy channel. In this protocol, the sender only sends one frame at a time and waits for an acknowledgement from the receiver before sending the next frame. This helps to ensure that the receiver receives the data correctly and eliminates the need for retransmission in the case of errors caused by the noisy channel. The sender continuously monitors the channel for errors, and if an error is detected, it waits for the next acknowledgement before resending the frame. This protocol adds error control to the basic unidirectional communication of data frames and acknowledgement frames in the opposite direction. Second, Second, we can see the go back and automatic request protocol. The go back and automatic repeat request protocol is a type of error control protocol used in the data communication to ensure reliable data delivery of data over a noisy channel. In a noisy channel, probability of errors in the received packets is high, and hence there is a need for mechanism to detect and control these errors. At last, second, selective repeat automatic repeat request protocol is a type of error control protocol used in data communication to ensure reliable delivery of data over a noisy channel. Unlike the go back and protocol, which retransmits the entire window of protocols, the selective repeat ARQ protocol retransmits only the packets that were not correctly received. As I already mentioned, the stop and wait protocol. Let's discuss the flow diagram. A data flow diagram in the stop and wait protocol is a noisy channel can be used to describe the data flow between the sender and the receiver. This diagram generally includes the following components: sender, receiver, noisy channel, error detection, and error correction. In sender, the sender receives sends the data frames whatever time and waits for a response. Receiver, the receive data from and process them. If the frame is received correctly, the receiver sends an acknowledgement. Otherwise, it does not receive correctly. The receiver sends an NACK. It means not no acknowledgement to the sender. Let's about the discuss the diagram. You can see the frame one is sent by the sender to receiver in particular time, and the receiver sends the acknowledgement to one for frame zero. Next frame is sent and acknowledgement is sent also. Next frame, it is not received by the receiver, so again whole set of frames, frame zero, frame one up to n, is again resended. So it is the drawback, we can say. Second is go back and ARQ protocol. The go back and automatic request protocol is a type of error control protocol used in data communication to ensure reliable delivery of data over a noisy channel. In a noisy channel, the probability of errors in the received packets is high, and hence there is a need for mechanism to detect and correct these errors. Discuss the flow diagram. I guess the packet one is sent by the sender and received by the receiver. Second packet is also sent, but it is lost. But acknowledgement one, frame one is received by the sender. Second one is lost. Third one is discarded. Fourth one is also discarded. Again, the whole packets P2, P3, P4, P5 again resended. You already discussed about this. Third one is selective repeat ARQ protocol. The selective repeat ARQ is a type of error control protocol used in data communication to ensure reliable delivery of data over a noisy channel. Unlike the go back and ARQ protocol, which retransmits the entire window of packets, selective repeat ARQ protocol retransmits only the packets that were not correctly received. We discuss about the flow diagram. Sends a frame zero. It received the receiver also receives, but it does not send an acknowledgement. Next, frame 1 is sent, acknowledgement 2 is also got, and frame 2 is lost. Now, frame 3 also sent, acknowledgement 2 also get, but frame 2 also resended. In this, only the frame which is not acknowledged by the receiver, that is only resended. It's not like the previous protocol, like whole windows and whole set of window sliding window protocols are resended. This is the more optimized way. Sender slide in the if the sender slides an acknowledgement from the receiver, the sender returns only the packets that were not correctly received. Conclusion: the most optimized selective repeat ARQ protocol is the most optimized. Thank you.